In this lecture, we're going to take a closer look at some of the tests that are used to evaluate respiratory and ventilatory function. And what we're looking at here on this diagram is a test that is considered to be closed circuit spirometry. And what we see here is that a person is breathing into this hose, and this hose allows the movement of air into and out of the lungs. But as the person is expiring air and they're pushing out here, what we have in this device is a drum that sits on top of a very thin film of water. And that thin film of water will push the drum upwards when the person is breathing out, and when the person breathes in, will allow the drum to move back down. Attached to that drum is a pen with a rotating a cylinder with paper, and that will produce deflections that will indicate the magnitude of air that is inspired and expired. And the closed circuit nature of this means that this person is breathing within a closed system. And so the person is not exchanging air with the air around them. They're just exchanging air with the device. And so this is the device is indicated that measures the volume of air. This is not going to give an indication of respiration. This is giving an indication of ventilation. And the first assessment that is made is something called tidal volume. And tidal volume refers to how much air a person moves for every breath that they take when they are resting and they are not physically active. And in the average healthy adult, this value ranges anywhere from 400, maybe a little bit less than, a little bit less than 500 milliliters, up to as much as 600 milliliters of air per breath. And this is a sample tracing of the different variables that can be measured during a functional test, such as closed circuit spirometry. So what we see here over the course of time, and the volume is a measurement of the air that's moved, we see these relatively small deflections, and this is the air that a person is moving into the respiratory system. They're pushing it out, pulling it in, pushing it out. This is occurring during quiet breathing when they are relaxed. They're not actually moving. And the tracing all the way at the top here refers to maximum inspiration. And this is the maximum amount of air a person can pull into their lungs by maximally activating their inspiratory muscles. On the lower part of the tracing is maximum expiration, and this refers to how much air a person can push out of their lungs when activating those expiratory muscles. And the first observation that we see here is that the volume of air that can come into the lungs exceeds the maximum amount of air that can be pushed out of the lungs. And so on the right-hand side, we're just going to focus on just a few of these different measures here. Here we see tidal volume on average in the healthy adult lung is about 500 milliliters. The total lung capacity is a reflection of the size of the lung. If we take a look at the air that is pushed out of the lung, what we also have here is what's called a residual volume. And the residual volume refers to the amount of air left in the respiratory pathways even after a person attempts to push all that air out of their lungs. Now, the important aspect of pulmonary function testing is that it evaluates the strength of those both inspiratory muscles as well as expiratory muscles, and provides an indication of the mechanical state of the lung itself. And the one type of test that's carried out is what's called an MVV test, or maximal voluntary ventilation test. And this is a measure of how much air, the total volume, moved during maximal efforts. One such variable that is measured is what's called a forced vital capacity. And a forced vital capacity is a measure of how much air or a gas that can be expired after a person performs a maximum inspiration. So a person takes in as deep a breath as they can uh, while being assessed with the closed circuit spirometry device, and then they push out all the air that they can as quickly as they can. And a very important measure that is evaluated that we'll take a look at on the next slide in this tracing is called FEV1. And FEV stands for the forced expiratory volume in the first 1 second that a person maximally attempts to push all the air out of their lungs as quickly as they can after the maximum inspiration. Now, this is a measure that is particularly sensitive in individuals that have any pathological issues with any sort of obstruction or restriction. And specifically in patients with COPD, FEV1 is a strong statistical predictor of early death or mortality in COPD patients. Now, in the healthy lung, the ratio of the volume of air pushed out in the first second to the total amount of air should be approximately 0.8 or 80%. So during this test, a person with a healthy lung, with healthy lungs and a healthy respiratory system, as well as the muscles that drive the effort, will be able to push out approximately 80% of the total air that they can push out through that maximum effort. And this is a typical tracing that we see during MVV testing. So along the y-axis, along the x-axis here is a measure of time, and the 1 second period is the indicator that we'll be looking for. And of course, what we're measuring here is the volume of air. At the top end, what we see here is that the total amount of air in the lungs, which is total lung capacity in the healthy average adult, is about 5 liters. And so this dark tracing here is a measure that we would expect in a person that that is healthy, that does not have any sort of pulmonary condition. And we see that the volume of air that is pushed out, or this person's FEV1, is about 3.6 liters in the first second. So after a person takes a maximum inspiration, they immediately try to push all that air out of their lungs. Most of it, about 80%, will go in the first second, and then the remaining air that does eventually leave the lungs still leaves, but it starts to slow down and it trails off to this level right here. And so the difference between the amount of air that's pushed out and the air that's left in, you'll notice that this line does not extend all the way up to 5 liters, is the residual volume. And that's what's left in the lungs after the forced vital capacity test. And so in the average healthy adult, we see that the forced vital capacity is approximately 4.5 liters. Now, this value does vary a little bit, even within people that are free of any sort of pulmonary condition. Now, the lower purple tracing is a typical response we see in a person afflicted with an obstructed airway. And so the FEV1 we can see here is shifted or the 80% point is shifted to the right. So in the first second, the person is moving far less than 80% of the total air that they eventually push out of their lungs. And so it takes a longer time for this person to push the air out of their lungs, plus this person would have a greater amount of air trapped in their lungs after they attempt to push it out as much as they can. One last point to make on the pathophysiology and development of the disease and the worsening condition is malnutrition, which is always a concern in a person afflicted with COPD. And this is something that is experienced by approximately 25% of all COPD patients. And the one significant deficiency that is common in those COPD patients with malnutrition is a deficiency in protein. And a protein deficiency is particularly of concern because the protein deficiency will contribute to a worsening of skeletal muscle dysfunction. And so those negative changes that were discussed in the immediate previous lecture. And so as a result of these concerns, the COPD patient is considered to have a greater requirement for caloric intake. The greater caloric intake is necessary to offset the greater caloric expenditure that normally takes place in a person, that normally occurs in a person afflicted with COPD. Because of the increased cost of breathing and the difficulty a person has with breathing, they're activating those inspiratory muscles and those expiratory muscles to a greater extent. And so their energy expenditure goes up, their caloric intake should match that increase in caloric expenditure. And so the recommendation is to recommend that, or the recommendation here is to prescribe the person's diet to be in a caloric surplus. So the surplus refers to an increase in energy intake or caloric intake over energy expenditure. So this ends our second lecture of part 3.